Hey there, Joel here, and welcome to this online class. Today is the part 2 video of the chapter Fractions and Decimals. And if you haven't watched the first part, I'll give the link in the description box. Go ahead and watch that video, or I will put it over here on the I button. Watch that video and then come to this, or else you will not know the link of the chapter at all. So watch the first part and then watch this. Secondly, you need to know the tables properly. If you don't know the tables, then you will not be able to solve most of the questions. You'll find them very difficult. So you need to learn the tables. And I consider now that you know both these things and you've done them, and then we'll go ahead with this chapter. Arrange the fractions in the descending order. So you have learned in your lower classes that I can give you some numbers: 10, 2, 8, 7, 15, 23, 25, and then I tell you write them in the descending order. So when you're descending, that means you are coming from a higher number, from top to down. Okay, descending order. So a bigger number first and then the smaller number. So here we're not having whole numbers, we're having fractions. So how do we calculate them? So these are the fractions that I have: 5 upon 4, 1 upon 2 and 3 upon 5. Can I tell which number will come first? I can't, because if you remember initially in the previous video I've told you to tell which fraction is bigger, which one is smaller. First of all, you need to bring them on the same page. That means my denominators have to be same. If I have denominators same, then looking at the numerator I can tell which one is greater and which one is smaller. So how do I make those denominators same? I will write all the three denominators, if there are 4 numbers, all the 4 denominators in the rough column, and then draw a sign like this and try and remember a number, think of a number to get all ones. Okay, so let us start with 2. So 2 times 2 is 4. 2 1 time is 2, and in the table of 2 I can't get 5, so I will write 5 as it is. Next I will think of another number. So here also I have taken 2 because I need to clear that 2 from there, right? So 2 ones is 2, 1 will come as it is, and in the table of 2 I don't get 5, so 5 is brought down. Next I'll write 5, 1 will be as it is because in the table of 5 I don't get 1 at all, so I'll write 1 as it is, and 5 ones becomes 5. So I got 3 numbers now: 2, 2 and 5. Now I will multiply all these numbers together and get another number in total, right? So 2 multiplied by 2 multiplied by 5 will be 20. Now this 20 is a number which you have to remember. Okay, think of it. Now what I will do, since I want to make the denominator same, considering 4, okay, I will multiply another number so that my answer is 20. Okay, once again I did all this math, I got one value, a number which is 20, and you can think of it as a result, an answer. Now I will take the denominator of the first fraction, which is 4, multiply something of my own so that my answer becomes 20. Okay, and that would be, if you can think of, then if I multiply, okay, if I multiply 5, okay, 4 5s are, my answer will become 20. So same, I can't just multiply in the denominator, I have to multiply it in the numerator as well. Okay. This is for one fraction. For next fraction, 1 upon 2. I have 2 in the denominator. I will multiply something of my own so that my answer becomes 20. So in this case, I will have to multiply 10, and 10 will be in the numerator also. Okay, this is 10. Next is 3 upon 5. 5 is in the denominator. I will multiply something of my own so that my answer is 20. So here it will be 4 times, and same number I have to multiply on top as well. So after doing that, my answers will be 5 is 25 upon 20. The other one will be 10 upon 20, and it will be 12 upon 20. Now my denominators are same. So just by looking at the numerator, I can tell which number is greater and which fraction is smaller. Okay. So since we are talking about a descending order, bigger number comes first. So 25 upon 20 compared to the next two, 12 upon 20 will come next, and then 10 upon 20. But this is an equivalent fraction. What was the original fraction which we were dealing with? We were dealing with 5 upon 4, which will be as it is. 3 upon 5, okay, will be in the middle. So this is the descending order. I hope you are able to understand this. All I have to do is, when the denominators are different, I can't predict anything about the fractions, so I need to make the denominators same. Now to do that, could you multiply all those denominators like how we used to do when there were only 2 fractions? Yes, I could take this denominator, multiply over here, take this denominator, multiply over here, but then you will get one answer, then that answer you will have to do it again, and it is going to be a tiring job. Okay, so to keep it simple, just follow this procedure. Take the denominators, write them in the rough column, think of numbers, and make sure that you make all the numbers 1. Once you make all those numbers 1, the other numbers on the left hand side of that line, you multiply together. That's a value. Okay, that's a result. I'll take the denominator of the first fraction, multiply some number of my own, so that my answer becomes that 20 in this case. Okay, if you have understood this method properly, then solve these problems. Okay, and if you have not understood, then rewind the video and watch it again. Okay, and let's just go ahead with the chapter. Now, you need to solve these questions, and most of it you already know how to do. This will be of the part 1 video homework, the Langda party, which is the Langda here, 2. So to make the number, to give it a support, this 5 will be multiplied with 2 and then calculated, okay, under the same denominator. Same way, in this case, Langda party 4. Here, my denominators are different. How do I make them same? Take 5 and 7 in the rough column and then calculate, and then write the denominator once under the roof, and then add 2 and 3 or whatever the numbers that you get after multiplying. Okay, here again denominators have to be made same, and then you have to subtract it. Over here 3 numbers are there, 3 fractions. Again denominators have to be made same, so I'll take 10, 5 and 2, bring them in the rough column, calculate them, find them one value. That value will be multiplied to all the fractions and then calculate out. Please pay attention here. When you are finding the number fractions in ascending, descending order, that time we don't take the fraction and multiply it with that result. Only when we need to add or subtract, we take those fractions and then calculate them. So please remember the method properly. Do not mix anything anywhere and then it will become mixed bhaji. Okay, so avoid doing it. Know the method, right? What are you actually calculating? You know, those methods are, for this problem to solve, I need to use a similar kind of a method. For this problem to solve, it's the same method. So, you know, sometimes you don't know what to do, and then you just mess around with the problem completely. Understand what is asked. Here, in this part, you are not asked to put them in any order. You are asked to give one fraction. So that's the time you will take the numerator, denominator, multiply with the result, second numerator, denominator, multiply with the result, third fraction, multiply with the result. Those answers will be added later. Here, these are mixed fractions which you have to convert into proper improper fractions, and then check whether the denominators are same. If they're not same, make them same and then add them. Similarly, over here, 8 1 upon 2 minus 3 5 upon 8. In mixed fractions cannot be directly solved. You have to convert them into proper or improper fractions and then solve them. Okay? I hope you are very clear with all whatever is taught till now. Please practice these problems, because without practice you will not be able to solve them. Next one is arranging them in descending order. So you can try doing that. First one you can try in descending order. Second one you try in ascending order, just for practice. So when you are writing ascending order, the smaller number will come first and then we'll go higher. We ascend, we go up. When we sing descending, we go down. Next one, a rectangular sheet of paper is 12 1 upon 2 centimeter long and 10 2 upon 3 centimeter wide. Okay, now basically they are asking you what is the area of this. Okay, so find the area. Alright, so what I have to do, or you can say first you will find out the perimeter. You already know the method of finding the perimeter. You have to add the length, the breadth, the length and the breadth, all these numbers together, and then you get the perimeter. Okay, first what you have to do, it's a mixed fraction. So the moment you look at that question, you should be able to understand the basic idea. What am I doing? I need to convert my mixed fractions into something that is solvable. So do that first, and then you can add those fractions and then calculate what is the perimeter. Finding the area we will learn in the coming part of this video. Okay. Ritu ate 3/5 part of an apple and the remaining apple was eaten by her brother Somu. How much part of the apple did Somu eat? Who had the larger share? By how much? Just understand this. It is one apple. Okay, there are not two apples, huh? It is one apple. So let me just draw with a dirty handwriting, dirty drawing of mine. Okay, now this apple is divided into 5 parts, right? Because Ritu ate how many? She ate 3 of the 5. So you can imagine this is 1, 2, 3, 4. Just minute. They have to be equal parts. Okay, remember that. So Ritu ate 3 upon 5. Alright? Now, if Ritu ate 3 upon 5, how many parts are still remaining? Total have to be 5, right? So, 2 parts are remaining out of 5. 3 she ate out of 5 and 2 are left out of 5. So, this addition will give you 5 upon 5. How am I adding them? I can add them directly only because my denominators are same. So here 5 upon 5 means the entire apple. So 3/5 Ritu ate and 2/5 Somu ate. Right? So who ate the larger share? 3 pieces, right? So Ritu ate more. And by how much means we will have to minus it. So Ritu eats 3 pieces and Sumu eats 2 pieces. So how much was it more? 1/5, right? 1 piece extra. That's how the problem works. Simple as that. When you read it, it looks very complicated. A raw figure, it will be simple. Alright. Let's try this problem for homework, for practice. Michael finished coloring a picture in 7/12 hours. Vaibhav finished coloring the same picture in 3/4 hours. Who worked longer and by what fraction was it longer? So whenever you are saying or whenever you want to find out, okay, who worked longer, you will have to convert those fractions, the base same, then only you will be able to solve. Okay, remember this, 2 pens. If I want to find out which one is taller, which one is smaller, I will have to keep them closer and put them on the same base, right? Keep them on the table and keep this base same. So same way you will have to convert that 7/12 as a fraction and 3/4 as a fraction under the same base. So both should have the same number, or other you have to find out the equivalent first and then you will be able to tell which one is greater. So who worked longer will be the answer there, and what fraction, by what fraction it was greater, you will have to subtract those from bigger number and smaller number and you will find out the difference in that value. Multiplication of a fraction by a whole number. So I have a fraction and I have a whole number. I will multiply them. Again, the same pizza, I gave you 1 piece, right? And you ate it. And then you said, you know, I like this pizza so much. So how many pieces do you actually eat? You ate 1/6 of that pizza. Right? So 1 piece out of those 6 pieces. After that you say, I want more of it. And then you eat the next part of that pizza. You ate another 1/6 of it. So total will be what? So you ate 2 pieces out of those all 6 pieces. Or you can say 2 times 1/6 of the pizza is equal to 2/6. So what have I done? I have just taken this number and multiplied with this one. So 2 ones are 2/6. So this is a whole number and this is a fraction. So multiplication of a, ignore the sound please, multiplication of a fraction with a whole number or by a whole number. So I hope this is very clear. Simple. We just have to take the number and multiply only in the numerator. Okay, when you are multiplying fraction and a number, they are multiplied only in the numerator. You can try out these problems. So here 2/7 is multiplied with 3. 2/7 is a fraction, 3 is a whole number. So 3 2 times will become 6/7. Same way you can try this one and this one. Now to solve this problem over here, what you'll have to do? It's a mixed fraction. First make it proper improper and then multiply it with 6. Now sometimes, like even in this case, I can take the numerator and denominator and divide them to get the lowest possible form. That we are going to see in the coming problems. So 1/4 of 16. Remember this, when I use the word of, okay, it represents multiplication. So 1/4 of 16 means, let me just write it for you over here, top right, okay, 1/4, 1/4 of 16. That of is nothing but multiplication. So this will become 16. Okay, so 16/4 4. So whenever you are told that the word of is used in a word problem, you need to understand that it is multiplication. Because if you don't have the clue of these special words, right, then it becomes difficult to understand. Any word problem, that becomes your state if you don't understand these words. So of means multiplication. Now, multiply and reduce to the lowest form and convert it into a mixed fraction. We have always tried to convert a mixed fraction into proper or improper fraction. So let us try and solve the first one. 7 whole number multiplied to a fraction, 3 upon 5. So what will happen? 7 multiplied by 3 upon 5, which will give me 21 upon 5. Now I need to write this into a improper or a mixed fraction. So what I will do? All I will do is, whatever is my denominator, right, I'll start saying the tables in my mind. Okay? And I will say it to a point where the number is close to the numerator, not greater than numerator, but close to the numerator. So 5 ones are 5, 5 twos are 10, 5 threes are 15, 5 fours are 20, 5 fives are 25. Now 25 is greater than 21. So I don't go to 5 fives are. I stop at 5 fours are 20. Okay, so I can write denominator 5, 5 fours are. So 4. Now answer is 20, right? To get 21, how many numbers are we short of? We are short of one number, right? So this will become 1. So 4, 1 upon 5 is the reduced mixed fraction. Okay, we took a whole number, multiplied it with a fraction, and then reduced it to a mixed fraction. How do I convert? The denominator, I will start saying the tables and say the tables to a point that it is close to the numerator. So 5 fours are is 20 and we have numerator as 21. How far are we? We're just one step away, right? So 4, 1 upon 5. Let us take another homework. It's like, I'm solving your practice problems. So this would become 4 multiplied by 1 upon 3, which will become 4 upon 3. Again, think of the table, 3 in the denominator. 3 will be, start saying the table of 3, right? So 3 ones are 3. How far are we from 4? One step. So this would become, denominator remains the same, 1 and one step away. So 1 upon 3 is the answer. So I have multiplied a whole number to a fraction first and then got it to a mixed fraction. So like this, please try all these problems, okay, which are given, and you will be able to understand and solve them easily. Practice all of them. Okay, I hope you enjoying this video. If you are, then just don't forget to hit the like button. Okay, all these are for practice. Next, shade one or half of the circles in the box. I told you the word of means multiplication. Now, to shade those circles, I should first know what is half of it, and all I will do is write 1 upon 2 first, multiply because it's off. How many circles are there? 1, 2, 3, and 1, 2, 3, 4. So 4 3s is 12. So half of 12. 2 1s are 2, and 2 6 are 12. 6 1s will become 6. So I will color 6 circles, and that will be half of it. So same way you will have to do it for 2/3 of the triangle. So I will take 2 upon 3 multiplied by how many circles do I have? I have in total 9 circles, or sorry, 9 triangles. So calculate this part. The number that you get, you will have to color. Same way you can try for the squares as well. So let's clear this off now. You need to solve exercise 2.2 and problems which are in the 5th one, 6th one, 7th one and the 8th one. Please solve these problems because fractions and decimals will become a difficult chapter if you just watch this video and relax. I'm sure after watching the video you will understand how to solve, but unless and until you practice them, not going to happen. So please make sure you practice each and every problem, and if you're done practicing and you still want to solve more, then you can write some a comment in the comment box of this video, so that tell me that you want more problems, I will give them to you. Please solve these problems. Exercise 2.2, problem number 5, 6, 7 and 8. Multiplication of one fraction by another. So here we are not multiplying a whole number by a fraction, but we are multiplying two fractions together. So simple. All I will do is, whenever you are multiplying fraction with another fraction, multiplying, okay, remember the word multiplying. I said not addition, not subtraction, I said multiplication. When you are multiplying, all I have to do is numerator gets multiplied, denominator gets multiplied. Simple rule. Here we are not even bothered whether my denominators are same or different. We straight away multiply numerators to numerator, denominators to denominators. So 1 multiplied by 1 will become 1, and 2 multiplied by 3 will become 6. Same way you can try solving this and this and this and all these. Okay? Please practice the problems. If you practice, then it will be better. Here, fraction is given. What kind of a problem fraction is this? Numerator is small, denominator is big, is a proper fraction. What kind of a fraction is this one? It's a mixed fraction. Convert it and make it proper or improper, whatever you get it as an answer, and then multiply the fraction. So when you're multiplying one fraction by another, we don't bother about any numbers, we straight away multiply numerators together and we multiply denominators together. Okay, now take a look at this problem over here. 3 multiplied by 6 and 8 multiplied by 4. There are times when even before you multiply, you can cancel some numbers. How do we cancel? Imagine this. Think of a number. Okay, so in this case I'm remembering 2. So 2 times is 4. Which number is there in my mind? 2. So 2 times is 4, and 3 times is 6. So 6 upon 4, the equivalent fraction reduced is 3 upon 2. Okay, can I still divide anything? I can't. Now I will multiply these two numbers. So 3 multiplied by 3 will give me 9 upon 8 multiplied by 2 will give me 16. Okay, so that is how you solve. Sometimes you can't cancel them. Like for example, in this problem over here, I can't cancel any numerator and denominator. Cancellations when there is multiplication happens only in numerator and denominator. Only in multiplication, not in addition, not in subtraction. Addition and subtraction, I have already explained you in the previous video how to go about with it. Here, it is just a matter of multiplication. Numerator gets multiplied, denominator gets multiplied. Same way, you need to solve this. Now, I know most of you all have a little difficulty when you are dividing values, right? Dividing numbers itself. And now here it is fractions. So I have give you a simple technique how you have to solve this. First, I will write 12, okay, the first one, and then I'm going to convert this division into multiplication. So I'll write this divide sign into multiplication. So the moment you change division into multiplication, all you have to do is, write 4 on top and write 3 down. What was the fraction? It was 3 upon 4. And when I changed this to multiplication, that 3 upon 4 is reciprocated. Okay, that's the word to be used. I didn't tell you the word first because that's the reason. Whenever you are converting that division into multiplication, I will change the sign and 3 upon 4 will become 4 upon 3. Same way, ignore that sound. This division will be converted into multiplication and I have to write this fraction as 6 upon 5. Same way, multiplication and 3 upon 7. And you know how to multiply to a whole number and a fraction, right? So this will become 3 1s are 3, 3 4s are 12, and 4 4s will become 16 upon 1. This is your final answer for the first one. Okay, same way you can try all these problems. And if you have understood whatever I've taught in this today's video, then please don't forget to hit the like button. Like button is right here. Press this and subscribe to the channel. And comment whatever you felt about this video. If you understood, did not understand, if you hate this chapter, write whatever you felt like. Till then, take care and bye-bye. God bless you.